we've been talking about the water cycle this week. So we've been talking about it a little bit in brief, and we're going to kind of break it down a little bit more today. So first of all, to start off, we know that water is really important for us, right? I want to hear from you guys. Why do we think water is so important? I want to hear some answers. So you guys go ahead and let me hear some things. Okay, awesome. So what I'm hearing you guys say is we need water to live, right? It helps our plants to grow, all good things. Um, Humans and animals, we drink water every single day. We can't live without it. And like I said, it helps our plants to grow. Plants release oxygen. We need that oxygen to breathe and to grow food, the food which we later end up eating. So water is essential for us, for humans and animals to be able to survive, right? So a pretty big deal, which is why we're going to kind of talk about it some more today. So I'm going to share my screen real quick so I can show the image here. Let's see. All right, here it is. So we've got this picture here. This at the very bottom, if you can see my mouse circling that, we have our collection, also accumulation. They're kind of synonyms. I want to hear from you guys. What do we think accumulation means? Okay, yeah. So I heard you guys say accumulate means for it to build up in an area or to gather something in one area, and that's exactly right. So accumulation and collection, that's like our big bodies of water, our lakes, our oceans, any area where there's like a big gathering of water, okay? And that's where we're going to start with our water cycle. Okay, after that, and you see our picture of the sun right up here. The sun heats up the water at the top of our collection or accumulation areas. And when the sun is heating up the water, you see our little arrows right over here. The sun heats up the water and it starts to evaporate. Now, there's kind of a clue in the word evaporate. And I want to hear from you guys. What do you think is happening when we've already kind of talked about this? So let's see who remembers evaporation. What's going on there? Okay, yeah, I'm hearing you guys say like evaporation, the water is turning into a vapor. And this is really going to test you guys. When it goes from being in the collection stage, which is a what stage of water? Liquid, that's right. When it starts to evaporate, what stage are we in there? Yes, it's a gas. Okay, awesome. So when the water starts to evaporate, it's in the gas stage. It's little water vapor. So that those little bits of water vapor, they go up, 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 way up high, and it starts to then cool off again. So now it went from being too hot down here, turned to vapor, got up too high, and it's starting to cool off again. When it starts cooling off, it's starting to kind of form back into a yes, back into a liquid, right? So it's back forming back up into a liquid up here. It forms into our clouds. So it gets really cold up there, turns back into a liquid, or that's where our clouds are starting to form. And then we go into condensation. What's going on in condensation? Yes. Okay. Condensation is where, like I said, it's forming the clouds. We are going back from gas to liquid. And now the clouds start filling up more and more and more and getting heavier and heavier. And once they get too heavy, they can't hold it any longer. You see our dark cloud over here. Then the cloud gets so full, we start to have precipitation. And precipitation, what do we think is happening there? Yes, that's when we have our rain, our snow, sleet, any form of the water falling back down onto like our earth here. So once we have it precipitating, we have more collection, as you can see right here below. Then the water that fell gathers in another area. Accumulate means gather, like we said, or to collect water in a certain area. And that's where we have our big bodies of water, again, just like that. And so that's our basics there. That's our basics of the water cycle that we're going to discuss today. So let me unshare my screen here, and we're going to talk about it a little bit more. Okay, awesome. So now that we've kind of looked at that image to kind of help you visualize it, I'm going to teach you guys some hand motions to kind of help you guys remember and follow along. So first, we're going to start with, these are our waves, okay? So we've got our waves. This is our body of water. I want everybody doing it. We got our body of water here. These are our waves. The sun comes, heats it up, and then we have our evaporation, right? Up into the clouds, and our evaporation, it cools off, and it starts to form condensation, which is our clouds, right? Our cloud gets heavier, 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 and then we have our precipitation all the way back down to our, that's right, accumulation. Awesome. So now I'm going to say it and you guys are going to repeat after me. So I want to hear you guys saying it. All right. So we start with our accumulation. Okay, good. And then evaporation. Good. And then we've got condensation. Okay, good. And then we have our precipitation. Awesome. You guys totally crushed that. Okay, so now that we've kind of broken down the water cycle, we've got a little bit of an understanding there. I want us to kind of put that into work because like we said, water is so important for life. We can't live without it. And we know that water does not exist in just one form, right? It's constantly moving, constantly changing. And in order to kind of see how water is constantly changing, like we've just kind of gone through, we're going to kind of apply that to some real life problems. And to help us with that, Miss Amanda is going to walk us through some math problems to kind of help us combine the two and kind of visualize how water is constantly changing in real life. So here's Miss Amanda. Let's see. Okay.
Hi, boys and girls. I am going to pull a stick for somebody to tell me what you are learning about in science. All right, Sarah, can you tell me what you're learning about in science? That is right. You are learning about the water cycle. So I thought since you are learning about the water cycle in science, we could take what we're learning with that and apply it to math in the form of a math word problem. So I'm going to ask you to turn and talk to your neighbor to tell me one strategy you would use to solve a math problem such as Anna collected 2,352 milliliters of rainwater in a bucket for over a week. If she used 1,947 milliliters of the water for her greenhouse. Sorry, y'all, I messed it up. How much rainwater does Anna have left? Okay, turn and talk to your neighbor. All right, boys and girls. Yes, who can raise their hand that would like to share their answers of like what strategy you would use? You are correct. You would use our anchor chart, such as we have over here, called cubes. Now, we do have a little song that goes with cubes to help us remember. Cubes means that it's an acronym that helps us when we are wanting to finish word problems. We have circle the key numbers for the C, U, underline the question, B, box the math action words, E, evaluate, and S, to solve and check. So the little song that we've all been practicing, you guys know that, is C-U-B-E-S, C-U-B-E-S, hi-ho, the strategy I know, C-U-B-E-S. And so you say that little strategy just to help you with to do the word problem. So I will go back to my cubes and look at my word problem. And like the first thing that I see is for cubes, it says circle the key numbers. So raise your hand if you would like to tell me one of the key numbers that you see in our word problem. Yes, Sarah, can you tell me the key number, one key number that you see? Yes, 2,352. I'm just going to circle that. John, will you please tell me another key number? You are correct. 1,967. So according to my little anchor chart, I have circled the C for cube, part of the acronym for cubes. Now I've got to underline the question. Micah, what do you think my question is? All right, so you're thinking it starts here where if she used 1,967 milliliters of the water for her plants in the greenhouse, how much rainwater does Anna have left? Class, do you agree? Thumbs up. Yes, you are correct, Micah. So we're going to use this strategy. Let's see, box the math action words. So math action words is on another anchor chart. Remember, we have this chart that has keywords that helps us when we are doing math problems. So there are keywords for addition, keywords for dividing, keywords for subtraction, keywords for multiplication. So all of these words are words that you would see in a problem that would help you know if it's if you're going to divide, if you're going to multiply, if you're going to add, if you're going to subtract. So I'm going to give you a moment. Everybody go ahead and look at the keywords and see if you can pick out a keyword in our problem. All right, who can tell me a keyword? Okay. Joe, will you please tell me what you think is a keyword? Yes, I would agree. Left is a keyword because when we look on our anchor chart, it says left is up under which one? Add, subtract, multiply, or divide? Yes, it is. It's up under subtract. So with that, that means that we are going to have to write out our problem with the ones that we have circled, put them like that, and make sure we have them lined up in the thousands, hundreds, tens, and ones. So we've got that. And remember, since we said our keyword is subtract, we're going to use a sign to subtract. Now, there's more on the floor. So what does that mean? Yes, we have to go next door. So we're going to have to go to this 5 and make that a 4. Then this becomes a 12. So I always count up. So I've got 7. I'm going to put 7 in my head, and I'm going to count to 12. So 7, 8, 9, 10, 11, 12. And that gives me 5. I'm going to place 5 right up under that. Now, I've got 4 and a 6 on the bottom. There's still more on the floor. So what does that mean? Yes, I have to go next door. That's going to become, the 3 is going to become a 2. And this one is going to come a 14 now. Same thing, I can count up to 14. Put 6 in my head. 7, 8, 9, 10, 11, 12, 13, 14. So 7. And then I still have more, 8. Miss Amanda, she just can't count straight. All right, and then I'm going to go over here to the hundreds place, and there's still more on the floor. So I'm going to have to go next door. I'm going to make that 2A1, and then that's going to become a 12. Now, there's still So I'm going to put 9 in my head, 9, 10, 11, 12, and that's going to give me 3. All right, now I'm going to go to the thousands place, and I've got 1 and 1. And if I have 1 and I take away 1, there's just a 0. Now you can bring down the 0 or you can just leave it off, but just so that we can see it, we will go ahead and put a comma after that because we're just going to bring it on down. And our answer is 385. So when we're doing word problems, we have to figure out what is it that we're trying to find out. So like, is it 385 drops of water? No, it is 385 milliliters. And I don't have to write out the whole word milliliters. I can just abbreviate it by putting an M and an L. And that's our math answer for how much rainwater Anna collected. All right, just back to you, Miss Blaine.
Hey guys, all right, thanks. So now that you've reviewed the water cycle with Miss Suze and reviewed how to subtract 4-digit numbers with Miss Amanda, we're now going to do a little activity that involves both of these. It's going to be a mystery game. We need to find out how much water is going to be left over at the condensation stage of the water cycle. Now, we know the water cycle does not end, but for the sake of the game, we're going to stop at the condensation stage, which is the last stage before the cycle repeats itself. So we're going to start out with a number, and I am going to give you a piece of paper for you to work with and work on. This is what it looks like. Just remember to write your name on the top, so when you turn it in, I know whose is whose. Anyway, so we're going to start at the precipitation stage with the number 9,290 of liquid water. You will then subtract from a number I will tell you to get an answer. The number will also be located on your paper. So just in case if there's any miscommunication or you can't remember what I said, it's also located on your paper. Now, you may be wondering why we are subtracting and not adding. Can anybody raise their hand and tell me why you might think that? Okay, awesome. That's right. This is because the water is leaving one portion of the water cycle and going to the other. This answer you will get from subtracting the two numbers will help you in the next step. Now, I'm not going to share with you what the answer is for each step of the water cycle. I will go through the game at the end so we can talk about it. So you'll have the answer at the end of the game. Your goal is to have the correct amount of water at the condensation stage. And that would be the mystery number. This means you must be careful when subtracting, because if you make just even a simple mistake on one subtraction problem, you will mess up on the remainder of their problems as we continue throughout the water cycle. Now, can somebody tell me a strategy that you can use for subtraction? If there's a problem where you just can't remember by memory your subtraction facts, like, can somebody tell me? All right, awesome, great. I'm glad that you looked over at our anchor chart that we have over there of our subtraction strategies. Number lines, you can draw a number line out and use that number line. You can cross and count. You can count up, you can count back in your head. Awesome. So again, here's the paper that you will use to fill out and complete your work on. I will give you time during each step to complete your problem. I, of course, will walk around and help if needed. But again, I'm not going to tell you the answers or anything like that. We're going to go through it at the end. All right, are you ready? Okay, here we go. We are starting with the number 9,290 of liquid water. 4,188 of that water is leaving the precipitation stage and going to the collection stage. Now, how much water is considered to be lost by runoff and other means? So at this point, go ahead and work that problem out. I'm going to give you some time. Okay, awesome. It looks like everybody's ready to move on. So this is the next step. You are now going to take the answer that you used from the last step
from the precipitation step, and you're going to use it to subtract, to take away this number from it. You're now going to take away 1,210 from the collection stage, which that answer will then go into the evaporation stage to see how much of the water is turning into water vapor. Go ahead, take some time, work it out. Remember your strategies. Okay, awesome. Now, this is the last step. So far, I see all of you are doing a great job. Take your previous answer from the last stage and subtract the number 2,295. Go ahead, take some time. Awesome. At this point, you should have your final answer. So go ahead and make sure you have that final answer in that spot, because in a minute, we're about to talk about it. All right. Before we move on, I would love for you to use your shoulder partners to turn and talk to debrief your final answer. Did you get the same mystery number? Did you get different mystery numbers? Go through each of your work to figure out what things you may have done similar or different, depending on what each one of you used and what strategies you used. Okay. Awesome. I heard some great conversations. I would like a group to share their findings. Okay, so I see that this group got the same number. Okay, so they were able to work out the problems and they made it through and got the same number. Okay, now this group over here, they didn't get the same number. Why do you think y'all didn't get the same number? What do you think happened? Okay, I see that some of you, or one of you might have messed up on subtracting a problem and you were one number too high or one number too low. And that seems about to be the general consensus of this. And that's okay. We just have to make sure that we are very careful and we work slow and take our time through these problems. So great job. I really liked how y'all were talking to each other and talking about the math. All right, so at this point, I'm going to walk us through the steps in order to reveal the magic number or the mystery number. So then I would walk through and go through the whole steps again with the class. Okay, so now we see that the mystery number was 1,597. So you guys did such a great job today. I love how we talked about the water cycle and incorporated some math that we are currently learning. Before you leave, please complete a ticket out the door. This ticket out the door, I need you to tell me 3 things that you learned from the whole lesson, 2 things that you might need a little bit more work on, and then 1 thing that you feel like you could teach somebody else in this class. Okay, so that was Group 2's project on the water cycle being taught from a math perspective. Thanks for watching.